back in our pre-calc 1 class, we talked about odd and even. And when we talked about odd and even, we talked about symmetry. When we talked about odd and even, the way that we defined it before is if we have this function f of x, if I put in a negative x into my function and I get the exact same function out, then this function is even, which means we have symmetry with respect to the y-axis. So it is an even function and symmetric with respect to WRT, with respect to the y-axis. Okay? So on this, we're going to talk about odd and even. Now, it's going to make a lot of sense when we start graphing these, which we're not doing yet. So we're talking about odd and even. And what this allows us to do is if we know the function is even, then if I'm asked to find the sine of, say, negative 30 degrees, if it's an even function, it would equal just the sine of 30 degrees. The other way that we define our function is odd function. So if I have f of x, f of negative x is equal to negative f of x. If this happens, this is an odd function, which means we have symmetry with respect to the origin. So I have symmetry with respect to the origin. And in particular, sine is one of the ones that is odd. So if I want to know the sine of negative 30 degrees, I can write this as the negative sine of 30 degrees because sine is an odd function. So I can just evaluate the sine of 30 degrees and slap a negative on that answer. Yes?
What is the WRT change?
With respect to. WRT is with respect to. Any questions so far? Yes?
What does it mean, like, with respect to the y-axis and the origin? Like, does that mean that?
So when we talk about symmetry with respect to the x or y-axis, so let's just take a look at one that we're familiar with back in pre-calc 2. So back in pre-calc 2, we had this function right here, which is x squared. This is an even function. What that allows me to do is say, since this is an even function, we know it's even from pre-calc 2, and I can just put in, just to check it, if I have f of x is equal to x squared, f of negative x is equal to negative x, the quantity squared, which is exactly what I came out with. What odd and even says when I have symmetry with respect to, this allows me to put in 1, a positive 1, and get the same answer as if I put a negative 1 in there. I'm going to get the exact same answer. So I have that symmetry over, so whatever happens on this side of the y-axis, then I have a matching pair on the other side of the y-axis. So that's symmetry with respect to. Now the odd functions, we're going to go to an odd function that we're familiar with in pre-calc 2 or pre-calc 1, is the cubed function. So this is x cubed. So for the x cubed function, if I want to check for it to see whether it's odd or even, I get negative x cubed, which means that I have symmetry with respect to the origin. So that tells me that if I put in, say, 2 and I get an answer, I put in a negative 2, I'm going to get the negative of that answer. So I have symmetry over the origin. So I have a mirror image from here to here. Does that make sense? So that's when we're talking about odd and even. Sine is one of the ones that is odd. So if I'm asked to evaluate the negative sine 30, I can evaluate it as the sine of negative 30 is just negative sine of 30. So if I'm asked to evaluate the sine, because I know it's an odd function, of negative 120, then I can just say, oh, I know what the sine of 120 is, and I just slap a negative on the answer. Yes?
So when we're evaluating symmetry, are we only doing it if there's a negative in there? I mean,
well, when we go to graphing it, knowing the symmetry is going to help us. For right now, all we're doing is, can I evaluate, how do I evaluate the sine of negative 120? I can evaluate it at the sine of 120 and put a negative on the answer. So right now, we're just getting prepared for identities, basically. And it's going to help us when we start going into deeper into identities, and it's going to happen shortly.
So if you have like a sign and then you put a negative on it, if it comes out negative, then that's how we're seeing if it's the same.
So, all right, get your unit circle out and find the sign of 120.
Square root of 3 over 2.
Okay, so if I asked you to just simply evaluate the sign of 120, this is the square root of 3 over 2. But that's up in quadrant number 2, okay? The sign of negative 120, so if I want a negative 120, I'm actually down here, which is in quadrant 3, and sign should be a negative number. So if I'm asked to evaluate the sign of negative 120, it is the sign of 120 with a negative on the answer. So I can write this as simply negative square root of 3 over 2.
So it's symmetric about the x-axis then?
We have no symmetry on the x-axis because it's not a function if we have symmetry with the x. All right, when we get to the waves, trust me, you'll be better when we get to the waves.
I like waves.
We're all going to like the waves when we get to the sine and cosine waves. So odd and even functions. Every one of these are either odd or they're even. So there's none of these that are going to be neither unless we have a combination of these functions. Every one will be odd or even. If we go back to the unit circle, we know that when we're looking at the unit circle, in this quadrant, all of them are positive. In this quadrant, the sine is positive. In this quadrant, the tangent is positive. And in this quadrant, the cosine is positive. Okay? We have these. Cosine is even. See when I put in the negative theta in? Cosine itself comes back out. Cosine is even. Secant, which is the reciprocal, is also even. All the rest of them, when you put in a negative, are odd. So all the remaining trig functions are odd. All the remaining trig functions are odd. Yes? As long as they're not multiplied together or added together or anything, it is true, yes.
So if it's even, it's symmetric or?
Okay, so the question was if it's even, is it symmetric? Well, yeah, this is what the cosine wave looks like, give or take. Because we have symmetry with respect to the y-axis, the other side is going to match with a mirror image. But we're not there yet.
So cosine could be negative and be even.
If cosine is negative, then all that means is we're going to have a transformation of graphs and it's going to look like this. How about we just wait on that? Just trust me. I'm excited that you're excited about those, but let's just hold that thought for a minute.
Well, it's just because you have negative cosine is even, but positive secant is even also?
So the way we define odd and even, again, back from pre-calc 1, when we first learned odd and even, is that these have to hold true. So those have to hold true. That's how we define odd and even, with symmetry with respect to the origin or the y-axis. So coming down here, and they're telling me that if I put in a negative, this is equivalent to saying I have a negative x. Right here is saying this is equivalent to the cosine of negative x. That when I put in the cosine of negative x, I'm putting it, this is equivalent to thinking of this as f of negative x, because cosine is a function. So when I say the cosine of negative x and I end up with just the cosine of x, that's an even function. Just like when I put in negative x and I get my exact function out, that's how we define an even function. So for cosecant and secant, that will hold true. All the rest of them, when I put in a negative x, equivalently, what I'm saying is I have the sine of negative x. I get negative sine x out, This is equivalent to I put a negative in my function and the opposite of my function came out. That's just how we define it.
I think once you get some examples, I think it makes more sense.
Yeah, just hold. Just hold. So if I'm asked to find whether or not these are odd or even, then all I'm asked to do is put in that negative angle. That's it. So all I'm asked to do is put the negative angle in here, and I'm trying to decide what happens, what kicks out. So based on the fact that I know that cosine is even, I'm not going to do any of those. I'll do a different one. So if I was asked to find if I have the sine of theta, cosine of theta minus the sine of theta, this is my function. And I'm trying to determine whether or not this is odd or even. Then the first thing I'm going to do is put in the negative theta and see what happens. So I do the f of negative theta, which is the sine of negative theta, cosine of negative theta, minus the sine of negative theta. So what I know is sine is odd, so I know that this is going to be the negative sine of theta. I know that cosine is even, so this is just going to be the cosine of theta. Sine again is odd, so it's going to be minus the sine of theta. So my final answer, when I clean it all up, is the negative sine theta, cosine theta, plus the sine of theta. To determine whether it's odd or even, I ask myself, did every sign change between terms? Did every sign change between terms? If the answer is yes, then this is odd. If the answer is no, then I ask myself, did every sign stay the same? If the answer is yes, then it's even. If the answer is no, then the final answer is neither. Notice how every sign changed. I went from a positive and a negative to a positive. So this particular function is odd. Does that make sense?
Oh, yeah.
So like if we had tan cosine minus tan.
Okay.
That'd be the same thing?
Yes.
Okay, no problem.
All right, please do these. Okay, so I'm asked to put in a negative x into the function on the first one, and so it is the f of negative x is the cosine of negative 2x. But we know that cosine is even, so this is just going to be the cosine of 2x, so this function is even, because the sign didn't change. How was that? Okay. The next one, again, I'm going to put in a negative x, and so I have 2, the sine of negative x, the cosine of negative x. Cosine is an odd function, so that negative is actually going to come out as a multiplier. So it's going to be 2 times negative 1. So just negative 2, the sine x, and the cosine is even, so it's cosine x. So is this one odd or even? It is odd. I only have one term here. I have 2 factors in one term, but I only have one term. And I started out with a positive here, but when I got done, I ended up with a negative. So this one is odd. I'm going to do the same thing with the next one. This time, though, I'm putting in alpha. So f of negative alpha is equal to 1 plus the cosecant of negative alpha, not infinity, negative alpha. Cosecant is the reciprocal of sine. Sine is odd, so cosecant will be odd. So this is 1 minus the cosecant of alpha. Odd, even, or neither? This one is neither. So I ask myself, I started out with a positive and a positive, and I end up with a positive and a negative. So not both signs change and not both signs stayed the same. So it is a neither when I have a mix of sign changes, and I don't have everything changing or nothing changes, so this is a neither. On my last one, I'm going to put in a negative beta, so f of negative beta is equal to negative beta cosine of negative beta. Cosine is an even function, so the cosine of negative beta is just the cosine of beta. So it is negative beta cosine of beta. I went from a positive to a negative, odd, even, or neither. It is odd.
So when you're given a double negative like that, you just ignore the one on the left and just focus on what's inside the box.
You mean this part here?
Yeah, I mean, what's inside the box.
So the negative on the beta has to, I can't ignore it because beta is a multiplier. So unlike this one above on here, that 2 is just a multiplier, so I can pretty much ignore the 2 itself. But because beta is a multiplier and it's one of the things I put a negative into, it's going to just stay negative, unless, of course, if I would have had this, if I were asked to find f of alpha, and it is equal to alpha sine alpha, and then I'll have double negatives, and so this will end up being an even function. Does that answer your question?
Yeah, that's what I did. It canceled out.
Okay, so in this case, sine of alpha, alpha sine alpha, this one is an even function because I'll have double negatives, and so I come back to where I start. So of course, now is the time to simplify these, knowing what you know about odd and even. On this first one, I know that the sine of negative x, this portion is equal to negative sine x. And I know the cotangent of negative x is equal to negative cotangent x. So I have double negatives, and this will become positive. So it ended up being the sine of x, cotangent of x. But cotangent is cosine over sine. So this is equal to the sine of x, and then the cosine of x over the sine of x. Now my sines will cancel, and my final answer is just the cosine of x. I got some people really excited in the class. That's cool. How are we doing? How was that? Any questions? That wasn't bad. Cool. Next one is delicious. Okay, so on the next one, I'm going to deal with the denominator first. So I have the tangent cubed x minus the secant squared x, the tangent x, and then in the denominator, cotangent is odd or even? Odd. So this would be negative cotangent x. All right, now in the numerator, if I were to have gave you a to the third minus b squared times a, what would you have done there? Starts with a big old F word. Factor. What do I would have factored out? That's what you would have all done, right? So what do you think my a is in the numerator then? It's tangent x. So this is going to be tangent x, and then I'm going to be left with the tangent x squared minus the secant squared x all over the cotangent, negative cotangent x. How are we doing so far? Do we have any kind of relationship between tangent and secant? Looking at my Pythagorean identities. Do I have any relationship between tangent and secant in my Pythagorean identities? What is my relationship? So tangent squared of my angle plus 1 is equal to the secant squared of my angle. Alpha, we'll call it alpha. So I can rewrite this and say this is tangent squared alpha minus the secant squared alpha is equal to negative 1. Subtracting secant squared from both sides, subtracting 1 from both sides. So what does that mean up here? What can I replace all of that with? So I can replace that with a negative 1. So what I now have is the tangent of x multiplied by negative 1, so I'm just going to write it as the negative tangent. You all okay with that? and then minus and the negative cotangent of x in the denominator. What happens to my double negatives? They cancel out. So I end up with a tangent x over the cotangent x. Do I have a relationship between tangent and cotangent? Yes, what is the relationship between tangent and cotangent? They are reciprocals. So this is equal to the tangent of x 1 over the tangent of x. Cotangent is 1 over the tangent. I have a fraction within a fraction. My final answer is tangent squared x. That is my final answer. How was that one? Kind of annoying? Kind of not annoying, I hope? Kind of annoying? It's okay if it's annoying. How are we doing? How are we doing so far? Is this stuff okay, or is this stuff awful, or? It's not great. Okay. Whew, look, we get more identities. Here are more identities. And the identities just keep rolling in. So the way to read this, if you're looking at this, the cosine, these are the sum and difference identities. The way to read this is if the plus is in the top here, you look to see what the sign is in the top here. That sign is negative. So what I have is the cosine, if I have alpha plus beta, then this is going to equal the cosine of alpha, cosine of beta. The sign that's on the top is a negative, so it's a minus the sine alpha, sine beta. So whatever sign is on the top of the plus and minus is the sign that goes with each other. So notice again that since this is a plus, it is going to go with the minus here. This is a plus, it goes with a plus here. This is a minus, it goes with a plus up here, but a minus in the denominator. So that's how you read the plus and minus. Now let me get rid of all of that. Now, if you have nothing better to do this weekend and you're like, man, I really need to sleep, the proof for this lovely is in 10.4 in your book. Read through it. I'm not doing the proof in class. It takes too long. But it is a delicious proof. It's a nice proof. I'm not doing it. If you have nothing better to do, you need to sleep, get your book out. It'll help you. Let me know when you all had the opportunity to write these down, and or they are on your unit circle handout, the formula sheet that I give you. Okay. So what this allows us to do then, it allows us to break up our angles. So if I'm asked to evaluate the sine of pi over 12, and I want the exact answer, then I'm going to use the sum and differences to get pi over 12 with the angles that I know. So I'm going to break up the pi over 12 into angles that I know. So I'll have some angle that I know. And then I might subtract another angle that I know, or I might add it. So what I need is I need to find two angles that add up to or have a difference of pi over 12 that I know. The things that I know are I know all the multiples of 4. So I know pi over 4. I know pi over 6 and its multiples, and I know pi over 3 and its multiples. Those are the things that I know. I know those angles on the unit circle. Yes? Oh, that one too. Thank you. And pi over 2. Those are the ones that I know. Off the top of my head, I know what those are on the unit circle. So I need to figure out which combination will give me pi over 12. Do all of these have the same common denominator? No, so let's make them the same common denominator. So I know the same common denominator should be 12. So this first one I can write as 3 pi over 12. The second one I can write as 2 pi over 12. The third one I can write as 4 pi over 12. And the last one I can write as 6 pi over 12. Why did I write them all over 12? It is my common denominator, and it's also the thing that I'm chasing here. So what ones that if I add them or subtract them give me pi over 12? Which two will give me pi over 12? Yeah, so I can choose this one and this one, or I can choose this one and this one. Does it matter? No. You're going to get the same answer. Just depends on which ones you choose. So I can write the sign of pi over 12 as the sign of 3 pi over 12 minus 2 pi over 12. Because I know if I do that subtraction, I get 1 pi over 12. Do you all agree? But I'm going to put these back to the angles that I know, so I'm going to rewrite this as the sign of pi over 4 minus pi over 6. How are we doing? So now I can use the sum and difference. And the sum and difference is, this is going to be the sine of pi over 4 cosine of pi over 6 minus the sine of pi over 6 cosine pi over 4. Alpha and beta. Now I get my unit circle out. I know the sine of pi over 4 is the square root of 2 over 2. I know the cosine of pi over 6 is square root of 3 over 2. I know the sine of pi over 6 is 1/2. It's a really bad 1/2. 1/2. And I know the cosine of pi over 4 is the square root of 3 over 2, or square root of 2 over 2. My final answer is the square root of 6 minus 2 all over 4. And there's my final answer in exact form. How was that? Of course there is. Is there any questions before I have you all doing? Yes. Absolutely. Yes, absolutely. Okay. Here you go. These are yours. Ready, steady, here they are. These are yours. So for A, we're going to rewrite the cosine and angles that we know. We know 0, we know 30, we know 45, we know 60, and we know 90. There are two different ways of doing this. You know that the difference here between 45 and 30 is 15, so you could do that one. But if you're like, no, I like 60 and 45, cool. You can use those two as well. Doesn't matter which one you have, as long as the sum or difference is the 15 degrees. So you can write this as the cosine of 45 degrees minus the 30 degrees, or 60 minus 45 if you prefer. You're going to get the same answer. Once you have broken up into angles that you know, then you're going to use the sum and difference for cosine. This is my alpha, this is my beta. If I have the cosine of alpha minus beta, this is equal to the cosine alpha, cosine beta, plus the sine alpha, sine beta. So I'm using that sum and difference for cosine. Yes?
Wouldn't it be minus
No, so cosine is the opposite. So if I'm subtracting the angles, then in cosine I'm adding the two. Cosine has the opposite signs. So this is going to equal to the cosine, and what is my alpha?
45.
So cosine of 45 degrees. So that's that part. Then I'm going to do the cosine. What is my beta? That's that part. Okay? And then plus the sine of, what's my alpha again? What's that part? What is my beta? How are we doing? Now, when I look on my unit circle, 45, the cosine of 45 degrees is what? What is the cosine of 30 degrees? This is this, and this is this. So I'm just doing its replacements. Sine of 45 degrees? Sine of 30 degrees? This is this, this is this. When I get done, I'm going to get the square root of 6 plus the square root of 2 all over 4. How is that? Is that okay? Okay. So let's take a look at the next one. We are not going to finish it. We're just going to set it up and finish it tomorrow. What two angles that when I subtract them or add them give me a negative pi over 12? Well, sine, is that odd or even? Odd. So I know that sine is odd. I can write this as the negative sine of pi over 12 and just remember to put a negative on my answer because it's odd. I can do that. So what angles add up to or have a difference of pi over 12? Let's go back up here. Look, did I or did I not already do the sine of pi over 12? So my answer is just this value right here with a negative out front. So I already did this one for you because I love you all that much. Minus the square root of 6 minus the square root of 2 all over 4. And we're going to end with that, and I will see you all tomorrow. We're going to pick these up again tomorrow.